All right, everyone. I'm going to go through the slides again for exam 2. The recordings didn't turn out that great, so I'm basically going to do it all sort of in parts. So we're going to start today with section 3. Just want to point out sort of the key slides that you should be looking at as you're studying. So we'll go ahead and we'll start. Of course, the cover slide, where you should have pretty good working appreciation for that, sort of just for ADME, pharmacokinetics in general. But of course, you discuss that in detail as we go through. Slide 2, definitely knowing the 3 phases of drug action is going to be critical in your studying. Slide 3 gives a good background of ADME, sort of good definitions here. So I would definitely know those heading in. Number 4, sort of the journey for an orally active drug isn't necessarily too important. You could probably almost just X this slide out, but at least having a working appreciation of what's happening and sort of having an appreciation for the sort of the importance of a prodrug, which is discussed sort of in the next section, would be pretty important heading in. Drug absorption, understanding that amines in particular, why they're so valuable in drug discovery and drug development would be important. Knowing Lipinski's rules of 5 will definitely be important. So know slide 6. Slide 7, the log P determination is not going to be particularly important. You could visit the slide for a couple seconds, but you can pretty much X this one out. Slide 8, Weber's rules. I would have good appreciation for these ones. I would know them. It's likely going to be part of a multiple choice questions, very similar to Lipinski's rules. Slide 9, this is not particularly important, but I would generally know what pinocytosis is. Slide 10, drug distribution to the blood supply, tissues, organs, and cells. Having working appreciation for that, but I would say that not terribly important. I would maybe visit this slide for just a little bit. Blood-brain barrier and placental barrier will not be on your exam. That's slide 11. Slide 12, understanding what metabolite is and its importance, and that they're sort of produced in both phase 1 and phase 2 metabolism is going to be maybe a focal point, I would say, of your exam. Slide 13, phase 1 transformation, cytochrome P450 enzymes, knowing that the P450 does these oxidation and reduction reactions is going to be super important. And again, you do want to come up with maybe a list of enzymes and what they do, and sort of where they're going to be doing, let's say, an oxidation, for example, is going to be very important heading into the exam. Slide 14 is going to be important. I would definitely know that. Slide 15, knowing that in particular, P450s are going to hit sort of activated positions is going to be important. Slide 16, also important. Slide 17, knowing that you can also form epoxides or P450s, and then it could do, several different types of transformations after that, right? Epoxide hydrolase opens it up. The rearrangement, right, that we all hold near and dear to our hearts, the NIH shift is going to be important. And knowing that epoxide hydrolase can happen sort of both on sort of just simple alkenes and also cycloalkenes, but then on top of that, it also can happen once you sort of form that epoxide and aromatic. All those are going to be really important. Slide 18, you don't need to know this mechanism at all. Slide 19, that sort of reiterates what you saw 2 slides ago. You can go through rearrangements, epoxide hydrolase, right? Glutathione can add, and of course, macromolecular targets like an enzyme will likely appear on your exam. Slide 20, this is a good sort of depiction of what the NIH shift mechanism is. I would definitely know this. You're not going to have to know any deuterium labeling or anything like that. You just I would say knowing the mechanism, you can treat that deuterium as an H if you like, if that sort of simplifies things for you. Another good example of it, right, is down here in sort of this NIH shift to the chloride ion, really important. So this one, 21, is sort of a reiteration of what just mentioned. keep in mind those NIH shifts can happen for chlorine, bromine, iodine, nitro groups, but will not happen for fluorine. Slide 22, be important in the sense that it's sort of gives you an appreciation for its use. So once again, you're going to see this sort of in the context of, larger molecules. It could be really any drug that could select it might be able to go through this type of transformation. Really, anyone with aromatic is possible. I would say just use these as sort of nice sort of staple examples. I wouldn't spend a ton of time on it. 23 is important, that they can oxidize heteroatom centers is going to be important. Slide 24, that's a really good one, right? How do you lose a methyl, for example, adjacent to a ketone, right? Remember that those, if you sort of do the P450 oxidation and then that collapses to form formaldehyde, if it can dump its electrons into sort of the pi bonds of a ketone, right, then you can form the enolate. So keeping that in mind, I'll be a little more direct with sort of a more reaching type question with those ones, but definitely something to keep in mind. Cytochrome P450, the one in the bottom on slide 24, could be important in the sense that you can go sort of this one direction with it, right, where you actually you do this sort of deamination, where you form the ketone, but then sort of in the next slide, keep in mind, right, that can go the opposite way. Or I might show you that, it goes in the direction of forming the imine, right? So remember, so this intermediate in 8.18 is sort of the same, right, as the one in 8.48. So something to keep in mind. You'll be a little more guided on those ones, and then I'll show you the sort of starting material on the product. This oxidative end dealkylation on slide 25 is definitely going to be important. Slide 26, these are some examples. I would maybe take a peek at this just to sort of see it in practice. Slide 27, right? This is sort of reiterating sort of what has been mentioned in the previous slides. This is just demonstrating the presence of nicotine. So you can go ahead and, I would know that, but not in detail, right? It's all sort of the same types of transformations occurring. Slide 28. Yeah, I mean, so the key takeaway on 28 is going to be that, you can do the P450 oxidation and you can generate sort of an iminium ion, right, all the way to the right. But then, an 8 point, it eventually makes sort of this 8.70, right, such that, so, in the sense that like the amine or the amide, I should say, the amide nitrogen comes down, collapses to generate the corresponding cyclized product. And so, likely if you see that, I'm going to say this transformation occurred from 8.69 to 8.70. Can you give a good explanation for that? Right, so you'll start with 8.69. You say a P450 did the oxidation, it formed this iminium ion, and then that's cyclized. Once again, I'm going to give a quick plug for 3.5, section 3.5. I'm going to give a look at that. So those enamine, imine type formations are going to be important on sort of the reach questions for you. 29, you do not need to know that mechanism. 30, you do not need to know that mechanism. 31, I think having a good appreciation for what's happening here is important. This could be sort of in the area of a reach question, in such that you oxidize the nitrogen, that then has something added to it, sort of, let's say, through a phase 2 type transformation. And then that allows for the macro structures, for example, right, an enzyme to go ahead and attach to it. So because it has a good leaving group now. I would get a working appreciation for that. This might be one worth asking about in a review coming up or via email. Phase 1 transformation here. By P450, yeah, you're not going to need to know this mechanism in 32. 33, oxidation of sulfur containing functional groups. Definitely need to know that. Also that it does it on phosphorus. It's going to be important as well. Phase 1 transformation here, you do not need to know this one. 34. Continuing on phase 1. Yeah, I would say this example with tianilic acid is not particularly important at the moment, so you don't really need to study that one. The mechanism of a flavin monooxygenase will not be on your exam, but the important part of that is going to be on 37, where it can do these direct oxidations to the heteroatom. 38, dehydrogenases and monoamine oxidases are definitely going to be important. I would definitely know what those do. Reductive reactions in phase 1, keep in mind, these can happen via the alcohol dehydrogenases or ketoreductase in this case. And I would also keep in mind sort of reductive transformations do occur by P450s, right? So they do sort of the opposite reactions that they sort of do, so they do oxidations and reductions, right? Slide 39, I would say that one is important. Keep that in mind. 40 is definitely important, right? You do the reductive transformations here. Phase 1 reduction reactions, but again, P450s. I should actually say 40, those are also going to be done by P450s most likely. P450s will also do the reactions seen in 41. You do not need to know the mechanism at the top. In fact, you don't need to know either of these mechanisms. But I would say that, once again, getting a working appreciation of where sort of, arrows are moving in these would be good. It'd be good to rationalize them, a good practice for you. Acyl group reduction, knowing that can occur is great. I would say that knowing this mechanism is not important. There's just an example of that at the bottom. 43, reductive reactions of alkyl halides. That's important. Just know that can happen. I would say that I would not spend a ton of time looking at this mechanism. You're not going to need to know that. Esterases and peptidases will absolutely be on your exam. Like, you will definitely see these maybe multiple times. In fact, there'll be sort of entryways into sort of other aspects of some of the transformations that you'll see. So slide 44, I would star that. Slide 45, glucuronidase transferase will absolutely be on there. 46, the mechanism of glucuronidase transferase will not be on there. Knowing what can be glucuronidated, I guess, is definitely going to be on there. But I would say that's something once you know it essentially can glucuronidate a heteroatom for the most part. Continuing on with phase 2 transformations, the sulfate conjugation is definitely going to be on there. Sulfotransferases, something to note. Page 49. No, you don't need to know that mechanism. 50. Again, this is a good example, sort of very similar to the one that you saw previously, right? You get a P450 oxidation of the amide. That's followed then by sulfotransferase, right? It gives you sort of that leaving group, right? You saw this in the previous slide, right? And this is sort of a better outline mechanism of that, right? You generate what would be the Michael acceptor. If you guys remember, that one's ready for conjugate addition reaction. So that type of transformation will be on the exam for sure, most likely. And then after that, you have addition, and then you have tautomerization to get you to the final sort of product where it's been attached to the enzyme. Amidation, absolutely. The amino acid and acyl transferase will be important. You'll likely see something that starts with sort of the compound on the left, where the drug has a carboxylic acid, and then it has amino acid attached to it. You're not going to have to know the sort of ATP and co-ASH. That's just too much. You just have to say it's an amino acid and transferase. I'll know what you mean. And that transformation will be called an amidation. Phase 2 transformation amidations, you do not need to know the mechanism in 52. 53 is an example where they're sort of piecing together a whole bunch of these things. Now, this is a good example of what you might see on the exam, right? Sort of what happens and how do we get to, from A to B. 54, yeah, right. Glutathione addition, glutathione transferase going to be important on your exam for sure. I would know that one. 55. Yeah, I mean, so glutathione can react with all those things that we generate sort of in phase one, right? Those epoxides can react with sort of these alpha beta unsaturated ketones to give you the conjugate addition product. And you likely won't see the sulfur variant. I think that's a little hard to predict for you at the moment. You don't really need to look at 56, I don't think. 57, so these SNAR type reactions you likely won't see. I don't think it's on your exam. Although not a bad idea to look at this. This will definitely appear on an exam at some point. So not a bad idea to get that down. Examples of glutathione conjugation. This is happening through conjugate addition. So understanding what sort of conjugate addition is and sort of how that plays a role, right, with glutathione among other nucleophiles is going to be important. So I would spend some time on this slide. 58. 59, you do not need to know that mechanism. 60, right, having appreciation for, I mean, one great question I could ask you is something along the lines of, do all phase 2 transformations, make the molecule more polar? And that's not the case, right? So oftentimes, right, you have tunability in phase 2, right? Whereas if you've now made the compound too polar, right, it has some what I would call sort of adjustment enzymes almost to sort of tune it maybe not the polar direction, but the non-polar direction. So methyltransferases also will be on there. Acyltransferases for sure will be on there. And I would say those have oxygen and nitrogen variants. The methyltransferase also has a sulfur variant. I would keep that in mind. It's also not crazy to imagine having sort of this one in the top right, methyltransferase to a pyridine. Could ask that too. You do not necessarily need to know, right, S-adenosyl methionine. That's just a mouthful that you don't need to know. I just want in general, the enzyme that's capable of doing this. 61 is not particularly important. Man, 62, I hope now that you guys have been in class for a little bit, you can now see why this slide is particularly important. I'm going to have you sort of focus on sort of the left side, right? Areas that are prone to sort of oxidative degradation or functionalization, right, by P450, for example. This whole blocking and alkylation sort of on the right side likely is not going to appear until your next exam 3. Drug excretion, having an appreciation for that. 63, important. 64, give that a glance as well. 65, yeah, knowing the routes of drug delivery, I think is wise heading in. 66, definitely ask about the therapeutic window. That is definitely going to be part of a multiple choice question. Drug half-life and steady state concentration, I'll likely ask about those in the context of a multiple choice question. 68, formulation, bioavailability and formulation on here. Yeah, I would say to have a pretty good appreciation for that. Could be asked on a multiple choice question. 69, you do not need to worry about at all. So that's that for that section. And we'll I'll be heading on to the next section now.